So now I am going to discuss the trigonometric identities. So the first section where we're going to define an identity. So an equation in one or more variables is called an identity if the equation is satisfied for all the possible values of the variable involved in the equation. For example, we have a plus b whole square is equal to a squared plus 2ab plus b squared. It is an algebraic identity held for all a, b. And now let us consider, to give an example, a plus b whole square is equal to a square plus 2ab plus b square. So now let us assume the value for a as 2 and b as 3. And now substituting both the values in the given example, we get here 2 plus 3 whole square, which is equal to a square. That is 2 square plus 2ab. 2 into the value of a, that is 2 into b, that is 3 plus b square, which is 3 square. Here, so that implies we get here square, which is equal to 2 square, that is 4 plus 2 into 2, that is 4. 4 into 3, which is 12. And square root of 3, which is 9. So that implies we get here 5 square, which is 25, is equal to 25. So hence LHS is equal to RMS. So we can see that the given example is an algebraic identity held fresh all a, b. Let us proceed and establish some basic trigonometric identities and use them to draw some useful results. So first, we begin with the most fundamental one, that is sine squared theta plus cosine squared theta is equal to 1. And the second is most identity is cosecant squared theta minus cotangent squared theta is equal to 1. And then the next identity is secant squared theta minus sine squared theta is equal to 1. So let us consider first identity and prove whether this identity is true for all values of theta. So first, let us consider a right angle triangle ABC with angle B is equal to 90 degree and angle CAB is equal to theta. And here let us write the side opposite to the angle as the opposite side. So here we get BC as the opposite side and EB as the edges inside and AC as the hypotenuse. So let us first find the value of sine theta. So we'll already know that sine theta is equal to opposite side by hypotenuse side. So now let us write opposite side as BC divided by the hypotenuse side AC, and then coming to the value of cosine theta. So cosine theta is given by the formula edges inside by hypotenuse side. So writing the values we get here, AB by AC as the value of cosine theta. And then substituting the values of sine theta and cos it down and be given identity, we get your BC square by AC square plus AB square by AC square. So here we have common denominators, so we can write your AC square in the denominator, and in the numerator we get AB square plus BC square. And here, by using Pythagoras theorem, we can replace them by writing AC square. So hence your AC square gets cancelled and we get the result as 1. So therefore, sine squared theta plus cosine squared theta is equal to 1. It is a trigonometric identity. And now, let us prove whether cosecant squared theta minus cotangent squared theta is equal to 1. And now let us write the value of the secant squared theta and cotangent squared theta, so that implies we can write 1 by sine squared theta in the place of cosecant squared theta minus cosecant squared theta by sine squared theta in the place of sine squared theta. So hence we have a common denominator, sine squared theta. So let us write a common denominator of sine squared theta And within denominator, we get 1 minus cosine square theta. So we have, by using the first basic identity, we can write 1 minus cosecant square theta and sine square theta divided by the denominator sine square theta. And both the sine square theta gets cancelled. And we get the result as 1. So hence, we can say that the cosecant square theta minus cotangent square theta is equal to 1. And it's just for all the values of theta. Hence, it is an identity. And then, coming to the next identity, and that is secant square theta minus tangent square theta is equal to 1. So let us write 1 by cosine square theta in the place of square term, and sine square theta by cosine square theta in the place of tangent square theta. So we get your 1 by cosine square theta minus sine square theta divided by cosine square theta. And here we have a common denominator, cosine square theta. So we get cosine square theta in the denominator, and in the numerator we get 1 minus sine square theta. So by using the first identity, we can write 1 minus sine square theta as cosine square theta divided by the denominator, cosine square theta. So hence, its values gets cancelled, and we get the result as 1. So hence, we see the secant square theta minus tangent square theta is equal to 1. And it is true for all the theta value, and there is also an identity. And now, let us verify the equation for some known values of theta. So now let us assume theta is equal to 45 degrees and substitute it in the first basic identity. That is sine square theta plus cosine square theta is equal to 1. So here, by substituting the value, that is theta equal to 45 degree in the identity, we get sine square 45 degrees plus cosine square 45 degrees. And here the value of sine 45 degree is 1 by square root 2. So we get here 1 by square root of 2 whole square plus the value of cosine 45 degrees is 1 by square root of 2 whole square. So then implies we get your 1 by 2 as under 2 whole square is equal to 2. So we get 1 by 2 plus 1 by 2 whole square is equal to 2. So we get 1 by 2 plus 1 by 2, and as we have common denominator, we get 2 in the denominator, and in the numerator we get 1 plus 1, so that implies we'll get here 2 by 2, and here by simplifying 2 to get 2, 1 times is 2, and 2, 1 time is 2, so we get the result as 1. So hence, we verify the equation for theta is equal to 45 degrees. And thus, we can see that all these identities are true for all values of theta. So this was a basic introduction on trigonometric identities. Hope you understood the concept. Thank you.